Every language, every library, every framework all has something that really defines it, what makes it stand apart from something else. And for me, when I think of Qt, I think of signals and slots. Signals and slots are not a Qt-centric technology, but the way Qt has done it is just amazing. I've never seen anything that even comes close to this level of functionality. There are a few things out there that try to mimic it, but none of them really come this close. The problem with signals and slots is it's a pretty advanced topic, but it's also fundamental to understanding what makes Qt great. And if you read the documentation, it's a little confusing. Signals and slots are used for communication between objects. Stop reading. Don't go any further, because it's going to get really confusing. You're going to dive into the meta object system and mock and QObject and all the things that we've touched on so far before you even talk about signals and slots. Instead, simply scroll down to this graphic. I love this image. So you have an object that wants to communicate with one or more other objects, and we want objects to be able to communicate with multiple objects, one or many times. Yes, that's insanely powerful, and these objects don't even really need to know the others exist. That's what mock really does for us, the meta object compiler. It all goes down to the humble QObject, the base class of all Qt objects. This has signals and slots baked right into it. And if you scroll down, you go past all the functions, there's a ton of them, you'll see this. Public slots, public signals. Notice there's really no public modifier in front of this, it's just signals, because every signal is, well, public by default. Now you get all this meta object connections, so we can dynamically connect and disconnect signals and slots. Let me go ahead and explain. So let's say we have a light switch, a light bulb, a blender, and an alarm. These are four very different classes. None of them have a clue that the others exist. They're just islands in themselves. There's no inheritance chain whatsoever. But all of them have one thing in common. They're all QObjects. Now, because they're QObjects, they have this signals and slot mechanism baked right into it, which means you can do something like this. You want the light switch to control that blender. However, you want the blender to control a light bulb. And you also want the light bulb turned on or off by the switch in case the light bulb gets a little annoying. So you could do something like this. And if, let's say, the blender has a problem, or the light bulb has a problem, or the light switch has a problem, you want to turn on some alarm. And then later you realize that you don't want to turn on or off the alarm, so you could later delete that connection dynamically. That is awesome, and none of these classes even know the others exist. The meta object engine in the background takes care of all of this for you. And you can do this across threads, which is something extremely powerful and very advanced, way more advanced than what this course is going to cover. But once you learn this fundamental concept, it goes with you through Qt, no matter how advanced you get with it. Then when you bake in something like QML, again, an advanced topic that we cover in another course, which is user interfaces, you can then tie in dynamic user interfaces with classes in the C++ background. Now, you're inclined to believe that because this is so powerful, it's extremely complex, and it could not be furthest from the truth. Really, they have the answer right here in this graphic I told you to scroll down to. You have an object and another object, object 1, object 2. Object 1 has signals, object 2 has slots. You literally just say connect object 1, signal, whatever one you want, you can have multiple, to the other object, in this case object 2, the slot, and you can have multiple slots. This is extremely cool. So what do they look like? They look exactly like this. They look exactly like functions. This is just C++. There's really no magic to it. You don't have to learn some special syntax. To overly simplify this, let's look at our diagram again of the light switch, blender, light bulb, alarm, and let's just get rid of all of this stuff. And let's just overly simplify this. So we have a light switch and a light bulb. Everybody should have a light switch and a light bulb. Really, all we're going to do is define a signal. That signal will talk to a slot. That slot is a function. Now, it's got a couple special things in it. Now, when I say special things, all we're really doing is defining that it is a slot. And we do that right in the header. It's dead simple. We're going to demonstrate that in a future video. But think of it this way. We're really connecting a function to a function. That's really all we're doing. Now, the difference here is that you cannot call a signal directly. Now, what I mean by that is signals actually don't really exist. Think of it like a function prototype. It's just something we say is going to exist, but it doesn't actually exist. We let Qt build that for us in the background. A slot, however, can be called via a slot using the signal slot mechanism or directly as a normal C++ function. And a mock, the meta object compiler we've talked about, takes care of all of that in the background for us. That is extremely cool. Someone out there, no matter who you are, is going to say, why even use signals and slots? I get that they're baked right into QObject, but there are other ways of doing it. We have the simple diagram of a signal slot, say a light switch to a light bulb. Why even bother with this Qt technology? There's already things out there. So an example, you could use a callback in C++. There's other ways of doing it. However, they get very ugly. They get very C++ centric, and what I mean by that is you have to really figure out what's going on under the hood. Some of them are not thread friendly at all or thread safe, and you end up diving very, very deep into pointers, and there's also callables and all these other crazy things. The technology just constantly seems to change and rotate, and there's always a different or a better way of doing it. I don't like messing around with that. I want something that works, something that I know is proven and tested and will stand the test of time so I don't have to change my code a year from now. That's where signals and slots in Qt really come to shine. And if we scroll down, it's very, very simple. They say, okay, signals, slots, they basically explain everything that we just explained. And you can take a normal class, and you notice how you have these private and public sections here. We're just simply going to add a signal section and then define a signal. Notice how we're defining it, but we're not implementing it. This is never implemented. We're just simply making a definition out there. We'll talk about that a little bit later, but I want you to really remember that. Now, a slot, on the other hand, is something that you do actually have to define. So you'll see a public slot, and then you'll have your definition. Notice how it says void set value. When you go down, here is the implementation of that inside the class. It can be as complex or simple as you want, but it's just a function. The only real difference between a normal function and a slot is that you have the function definition under public slots or private slots or protected slots. As long as it's under the slots, it will automatically be converted by mock, and you can still call it like a normal function, but you can also send a signal to it. So when we go down, this is exactly how you do it. It's really that simple. You have two objects. You say QObject connect, and then you connect object 1 to object 2's, and it just goes. So when you emit a signal, the slot is automatically called. And we're going to demonstrate all that in that section. But just know that if you start deviating from this and you try going into the C++ standard way of doing things or another library or framework's way of doing something, you're going to get very confused very fast, and it's just not as straightforward. I often refer to this as the easiest way to do communication. You literally say, hey, this happened. You connect it to whatever you want it to, and they'll say, oh, thanks for telling me. And if you don't want it, you simply delete that connection. Now, you may be thinking, because this is so stinking cool and it is just very advanced, that it's going to be super complex and we're going to spend 3 hours showing how to do this. It couldn't be further from the truth. This is one of the simplest things in Qt to do, and it's just ridiculously powerful. So what are we doing? We are going to connect a signal to a slot, and we're going to walk through how to do that. Why? Because we just want to do it. We want to be able to communicate between two objects. And to do this, we're going to use the connect function. We're going to demonstrate some other things as well. So let's jump in here, and we're going to make two objects. So I'm going to say class. We want this to be the source. This is going to be a QObject. Make sure both of those are selected, QObject and add Q_object. That adds all that beautiful complexity in the background that mock is going to latch onto and make all this work for us. Next, finish. No, I don't want to automatically add it. And then add new. Let's call this destination. Again, base class should be a Qt object or something that inherits Qt object. And again, have those things checked. Next, next, finish. Let's go ahead and go and add these in. So we just have two very simple Qt objects. We haven't done anything at all. These are just very plain, very vanilla, and I'm going to close all these files out just so we can start. We're going to start with source. It's very simply just a class. We've done this before, but you notice we've got this signals thing that we haven't really talked about yet. So what I want to do is I want to add two things. I want to add a test function, and then I want to add a signal. And I'm just going to call it my signal. And just for giggles, we're going to pass a Q string back and forth. Now I need to pause right here and tell you, remember, Q string is not a Q object. That's why we can do this. We're actually making a copy. If you were trying to pass a Q object back and forth through signal slots, you're going to want to use a pointer. We've talked about pointers briefly. So really that's all we need, other than now we have to implement our test function. In here, we need to do a little bit of magic, and this is one thing I don't really care for too much, but it is what it is. We simply have to tell Qt we want to emit this signal. So we'll go in here and we'll say emit. It's just simply a keyword that's added in by Qt, and we need to emit the my signal along with some sort of message. Notice how it's going to automatically try to convert that to a Q string for us. That's it. That's just us telling everything that's connected to the signal that we are emitting it. Think of this a lot like shouting into a conference room full of people. You're just going to emit your voice and say, hey, this is happening. And anybody who's caring to listen will now listen to that and do something with it. It's really that simple. Also notice that we don't really implement this. We don't like right click and refactor, and there's not even an option to implement it. It just has to be under signals, and we have to have a definition. That's it. It's really that straightforward and that simple. So let's dive into adding the slot. So we're going to go to our destination. Now you notice one thing that's not there, slots. We have signals, but we don't have slots. We can simply say public slots. And yes, you can have private slots and a whole slew of other things, but we're going to keep it very simple. We're just going to say public slots, which are available to the outside world. And this, we want to add in something very simple. And now, usually what I do is I'll actually take the definition of the signal, I'll literally copy it, and I'll go to the destination and just paste it in. That way, it's a one-for-one match, and I know exactly what's going to happen. But you can name it anything you want. You could say fuzzy button, little kittens, fireballs, whatever you want to call it, doesn't matter. I usually just copy and paste the name. That way they line up one for one. I'm going to right click, refactor, and then add a definition. So the slot, we do have to define this. Again, public slots, we have it defined and we have to implement it. Switch over to the header there, or switch from the header to the implementation file. And here we've implemented it. Now let's go ahead and do something with that. So I'm going to include debug and we're just going to print this out. Very, very simple. Now, what's really the difference between this slot and just a normal function? Absolutely nothing. It is literally just a C++ function. We're just telling Qt that when we compile to add some mock goodness, or the meta object compiler is going to go in and add some logic behind here for us so that we can connect that signal and slot up. And last but not least, let's go ahead and do that. So we're going to jump back to our main, and we simply want to connect those two objects. So let's go ahead and make an instance of each object here. So I'm going to include source, and let's go ahead and include destination. And let's make an instance of each one of those. And let's simply call this O source. And let's make a destination. And let's connect the two up. So I'm going to say QObject. There's a couple different ways of doing this. We're going to cover both of them, but so I'm going to say QObject. So we're calling QObject directly, and we're going to call the static connect. And then we're going to simply get the address of our source object, OSource, and then give it the class name. And we want the signal. Notice how it's got the little, looks like almost like a Wi-Fi signal coming out of it. That's how we know those are signals. Now there's a slight bug here in Qt Creator. It's going to put the parentheses here, and we don't want those because we're not trying to call a function. So we're going to delete those and then comma. And notice how now it wants the receiver. Very, very similar. We want the address of, or a pointer if you're working with pointer. We're going to say the destination. And then I want the class. And we want the slot. Now, if you're ever confused about the name, you can simply look at the icons here and you notice these little red blocks, these are functions. And these look like little outlets. Those are slots. So delete later is actually a slot. We can just simply scroll down and look for that icon, my signal. There it is, slot. Again, it's going to put that annoying parentheses in there. Get rid of that. That's it. That's really it. So from there, absolutely nothing's going to happen. Let me go ahead and run and demonstrate this. So it's going to build it. Mock is going to come in and say, oh, I see you're using signals and slots. And it's going to wrap all that goodness in, but nothing's actually happened because we haven't emitted the signal. This is the basis of, well, event-driven programming. So what we need to do now is take our OSource and call our test function. Because remember, in this guy right here, what's really happening is we are emitting the my signal. So now that we're actually going to emit it, something magical happens. Hello world. What's happening under the hood is the signals being emitted. Qt has an internal thing in the background that's saying, look at all the signals and slots. Does it connect? If it does, because we made a connection, then go ahead and call that slot. However, you can, if you really wanted to, do something like this. destination, my signal. Now it's a little bit misleading. I don't like that name. So let's go ahead and flip in here. Let's call this my slot. We're just going to do some surgery here. That way you realize we're not calling a signal. And I'm also showing you how rapid it is. You can actually just change something here. And we can go ahead and say, hi. And we just call it like a normal function here. You don't even need to make a connection because we're not using it. Save, run. Let's see this in action. So the main takeaway here is that you can use a slot or as a normal function. It simply doesn't matter. But if you want that event-driven programming, you need signals and slots. Another major takeaway here is that you don't have to have all signals in one or all slots in another. You can have signals and slots in the same thing. So for example, I could say void, I don't know about arrived, because we've arrived at our destination. Notice how we have a signal in here. And we could, if we really wanted to, modify it and do whatever we wanted to do, or just leave it at that. It builds just fine. We don't even have to implement it. But you can have signals and slots in the same object. You can even connect signals and slots to the same object or to other objects. That's literally how impressive this is. It's that easy and it's that complex. Now we're going to dive into some of the more deeper end of the ocean here and look at some of the complexities, but I want you to understand Fundamentally, what we're talking about here is mock. We make a Qt object, we have signals, we have slots, and we simply connect the signals to the slots that we want connected. Let's make a little bit more of a complex of an example here. I want to talk about disconnecting, and this is something a lot of people don't even know about when it comes to Qt, is that you can disconnect a signal from a slot. And there are times when you're intentionally going to want to do this. So I've got a few classes already pre-made. I've got radio and station. They're just blank. There's absolutely nothing in there. Let's go ahead and fill out radio. So all we're going to do is under these signals here, I'm going to say void quit. So our radio is just simply going to listen to stations. So I want a public slot. And in here, I'm going to say void listen. And here's where we need to make some design decisions here. So I want a channel. And then I want some sort of name. And let's go ahead and some sort of message as well. This is what we're expecting to get when somebody calls this slot, whether they call it by a signal slot or by a function. Doesn't matter, we want to know about it. I'm also going to add in Qt6. And let's right click and let's go to add definition to radio.cpp. From here, I'm just going to copy and paste just to save just a smidge of time because it's not rocket science what we're doing here. We're just going to QInfo out the channel, the name, and the message. I just want to know that we're listening to something, and I want to know what it all is. All right, in the last section, we just very simply set up our radio. Now we're going to set up our station, and we're going to do it very similar, but of course a little bit different because we're going to do something different. All right, Qdebug, we're going to add that in here. So the station's going to actually broadcast. So when I create the station, I don't want to have to worry about forgetting to do something. So I'm going to set this right in the constructor. I'm going to say int channel, and let's go ahead and say 0, qstring, name equals, and just by default, unknown. We can flip over to the constructor here and make sure if you click that little light bulb, it will actually add it in for you. Otherwise, you'll have to type it in. Now, spoiler alert, I'm going to just copy and paste something in here. Just for now, you notice how it says this channel equal channel, this name equal name. We haven't filled those in yet, so let's jump back to our header. What I want to do here is go in and set these up. I'm going to say qstring name. There's a million different ways of doing this, but I'm just going to put them in the public section just because I want to be able to modify these at will without a getter or setter. I don't have to worry about it. Now that we've got all that set up, let's focus on our signals and slots. You notice what's missing here is a message. We've got the channel and the string name, but we don't have the string message. So we need to set up some sort of broadcast mechanism. So I'm going to say public slots void broadcast. And all we need is that message. I'm going to go to the radio real quick, and we've got this slot. Now remember, I have a habit of just taking this and copying it. That way I don't mistype anything. And we're going to go back over to our station. We want to make a signal. And we're going to call this send. That way, the function prototypes line up with each other. We don't have to worry about missing some sort of parameter or anything like that. So I've got send and broadcast. We need to go ahead and implement broadcast here. So I'm going to go to refractor. Let's go into our station. And then this is just ridiculously simple. We just tell Qt we want to emit our signal. So I'm going to emit send, and it wants our channel, our name, and our message. So from here, I can just simply say It's really that simple. Now you may be wondering, how come this one has this pointing to channel and then this in name? Because we need to differentiate between what is part of the function scope and what is part of the class scope, where we don't have to do that here because there is an invisible, this right there. We don't even have to worry about it. So we just simply don't need it. The compiler is going to take care of that for us, just in case you were curious about that. That's it. Our signals and slot mechanism is ready to use. Let's just go ahead and give this a good build and make sure we didn't goof anything up. Once we get a good solid build, we're ready to go. Now we're at the point where we can use our classes. I'm going to do a little bit of copy and pasting just to speed this up, but I'm going to slow way down when we get to concepts that we need to cover here. So we need some includes. We're going to include Qdebug, Qt6 stream, which does just, well, you guessed it, streams of text, IO stream, and then our radio and our station, and we're going to use the namespace std. From here, what we're going to do is we're going to make a new radio. Call this boombox. Notice we're doing this on the stack. Now, I don't like working with arrays. I think there's a better way, which we'll cover later on in this course, called lists or containers. We're just simply not there yet, so we're going to do it what we know so far, which is simply an array. Say channels, and let's give this an upper limit of 3. Notice these are pointers, so we're working with an array of pointers. That gets a little bit dangerous, and then you have memory management on top of that. So what we're going to do is create some stations. And this will scare some folks. So I'm going to say channels, and let's go with, actually do want to name that channels instead of channel. Let's go with channel 0. Is going to be a new station. Now notice the new keyword, that means we're playing around with memory. We're creating something out on the heap. But because our station is a Q object, the first parameter in the constructor is give us a pointer to the parent. This is Qt's built-in parent-child memory management. So I'm going to actually give it the address of the boombox. And now I need to follow the rest of the constructor. So I need to give it a channel. I'm just going to pick some random number, say 94, which is going to be the rock and roll station. So there's a couple key things happening here. We have an array of pointers. We're setting the first item in the array to a new station, which means it's being allocated on the heap. Because we're using new, we have to delete that memory, but we're kind of lazy as programmers. So we're going to set the parent to the radio. Notice the radio is on the stack. So when the radio is deleted automatically, it's going to delete all children it has as well. Very simple how that works. We don't even have to worry about memory management now. Go ahead and grab this. Now you may be asking, did you have to create a pointer? No, we didn't. I just wanted to demonstrate that. All right, so let's go ahead and set out 1 and 2. And let's say this is 87, which is the hip hop station. And let's call this 104, which will be the boring newscast that nobody listens to anyways. Notice how we have this potential memory leak from Clang Analyzer. Don't really even need to worry about that because, again, Qt is going to go through and wipe all that out for us. We don't even have to worry about it. But whenever it sees we have an array of pointers, it's saying, hey, you as the programmer should go ahead and delete those. A little bit more advanced than where we are right now, but I just wanted you to be aware of that's why you're seeing that. Now, from here, we need to connect. And what we're going to actually connect is the radio quit to our application quit. We want to be actually able to say, when the radio quits, tell the application to quit. So let's go ahead and say, instead of Q object connect, like we've done in the past, we're going to use the boombox directly. So I'm going to say boombox dot connect, and then it's literally the same thing. See how it's just a QMeta object connect. We've talked about QMeta object before. That's what the mock is looking for. And there's different overloads there. I mean, not really worried about it, but you can really look at this. It's kind of like diving into the mouth of madness. But at its core, it's very straightforward. You need a source, a signal, a destination, and a slot. So we're going to say the source is our boombox. I need to give that the address of, because it wants a pointer. And then I want to say the radio class, and we want the quit signal. Remember, you've got these little Wi-Fi things, denotes that it's a signal. From there, we need the destination, which we want the address of A, which is our Qt Core application, this guy right here. And we want to know what slot we want to call. So we want to say Qt Core application. And we want the quit slot. What that does is when we're in our radio and we emit this quit signal, our entire application is going to close. That is extremely cool. All right, now we're going to speed through a lot of this here. So I'm going to say I want a do loop. So I'm going to say do. And then we need to have a while true. Now, never do this in a production system, because basically what you're saying is loop forever, but I'm doing it for illustrative purposes. We are going to break out of that loop eventually, but really what we're doing here is we're telling the computer loop for all infinity, and that can get very, very dangerous. From there, I'm going to say Qt info, and we're going to just say enter on, off, test, or quit. Don't need the comma there. And we're going to do a Qt6 stream. Let's call this Qtn, and we want the std standard in. So all that's doing is reading cin, basically. It's reading the standard input stream. We're going to use Qt6 stream so that it automatically converts the data for us, as I'm about to demonstrate here. So I'm going to say I want a QString. So we're just going to get a string representation. Whatever they type in the line is going to equal the qtn dot read line. And then from there, I'm going to say dot trimmed. So it's going to take out any of that white space. And then I want to convert it to uppercase. So I'm going to say to upper. If that seems really confusing, all we're doing is reading the line, trimming the white space, and then converting it all to uppercase and shoving it all into one variable called line, which is a QString. That is actually pretty powerful right there. I love that so much. From there, all we're going to do is, well, you guessed it, we're going to make sure we have a connection. So I'm going to jump up here real quick, and I want to make sure we have some sort of connection here. I'm going to say for int I equals 0. And let's go ahead and say I is less than 3, because that's our maximum in our array. I plus plus. We're going to simply connect those up. So instead of retyping all of this, we're just going to grab this here. So we're going to say boombox connect, and we're going to connect something here. We're going to connect our channel, but we need to get that channel. So let's go here and say station pointer, and let's call this channel. There we go. And we're just going to get that position in the array. Now we have a pointer, and we can just work with this very, very simply. So I'm going to say boombox connect, and we're going to connect that channel to the station. And that station is going to have a signal called send. In case you're wondering where I'm getting all this magic from, it's right here. Go back to our main. And we need to make sure that lines up with something here. So that's got to line up with our boombox. And we want our radio listen. So very simply, all we're doing is we're going through each item here, and we are connecting the signals and slots with the radio and the station. That's all we're doing. We're saying, take each station. Whenever the station sends something, the boombox is going to listen to it. And we go out to that radio. You guessed it. Listen just simply prints it out on the screen. Seems a little backwards, seems a little convoluted, but that's really all we're doing, is we're just listening for things from each specific radio station. Not super complex once you wrap your head around that. But now all of these objects are connected. Now we need to determine what the end user is doing based off what they entered. So this is where copy and paste really becomes our little buddy here in our do loop. And there's better ways of doing this, but I'm keeping it overly simple. I'm going to say if the line they entered equals, and we want to know what they actually entered here. So if it was off, then we need to go through and say Q info, turning the radio off. And then we're going to do this for loop. We're going to go through every station here. Now, instead of connecting the channel or the station send, we're going to disconnect. And it's very simple. Instead of connect, it's just simply disconnect. You actually don't need to do that if you're closing your application. Qt does it for you automatically. But as a general practice, if you want to disconnect something, that is the way you do it. Instead of connect, it's disconnect. Very, very simple. Now, let's go ahead and go here and say Q info radio is off. Very, very simple. Now we have this nice little function. I'm just going to grab this. This is going to be kind of our boilerplate of what we want to do here. So we have off test or quit, actually on off test or quit. We haven't done on, so let's go back up here and let's say on. So turning the radio on. Now we've got each one of these and we're going to connect them. And because we're going to do that in on, we don't need this guy up here. And I'm going to comment him out just for demonstrative purposes. If it seems super confusing, when we turn the radio on, we are going to connect. When we turn it off, we're going to simply disconnect. That's all. Those objects will still exist in memory. We're just simply not going to listen to them if we're off, or we will listen to them if we're on. It's pretty straightforward from there. Now, I want to be able to test this. So I'm going to say line equals test. And let's go ahead and say testing. Now, for each and every channel, we need to do something. So I'm going to say channel. And we're going to go ahead and broadcast some sort of message here. And I'm going to say broadcasting live. I don't know what they would say on the radio. I've never been a DJ and I probably never will be one. But we're just going to have it print something out just so we can see that it is doing something. And then I want to say test complete. Just so that we know, hey, our test is actually finished. From here, I'm going to grab this, and we got one more. If we kind of scroll up a bit, we got to do quit. So we need to really implement that. There's quit, and we're going to say quitting. Now we can actually get rid of all of this. Don't really need it. And I'm going to emit the boombox quit. Just doing that to demonstrate you don't actually have to be in the object to emit the signal from the object. You just need to use the omit keyword and it will emit it for us. And anything connected to that signal will act upon it. Now in this case, quit is going to quit the entire application. In case you kind of glazed over that part here, let's go all the way to the top. See, boombox connect. Radio quit is going to call Qt core application quit, which shuts the entire application down. At which point, Qt's built-in memory management with the parent-child relation will wipe out all those pointers for us. All right, now you see how this potential memory leak keeps popping up. I'm not going to worry about that too much. You may get that, you may not. Just depends on your version of Clang and what you got going on. So I'm going to give this a build and just make sure we didn't mistype anything. Once you get a solid build, we're good to go. All right, we are ready to test. Now, I have a flaw, and it's actually right here. I'm going to note that before we do it, because I want to demonstrate why we have a flaw. But quick recap, We've got a boombox, we've got some channels, and these channels are going to broadcast if the connections are there. We can dynamically connect and disconnect those signals and slots, and we can test that broadcast across the signal and slot channel, and we can also quit. So when we call quit, that's where we're going to notice our flaw. But let's go ahead and demonstrate. So I'm going to save and run. All right, now if I say test, remember it's going to try to broadcast, but we don't have any connections, so nothing happens. That shows us that those objects are not currently connected to each other via signals and slots. However, if I type on, the radio is on, and we have now connected all of those. Let's go ahead and jump up here super quick. See, we're calling boombox connect, so we're connecting those signals and slots. Now, if I type test, we get those broadcasts. And we can do that over and over and over. We'll keep getting those broadcasts. If I type off, you notice how we are boombox disconnect. So we're disconnecting those signal slots. So I'm going to go ahead and disconnect that. Now, if I go ahead and test this again, nothing. We get absolutely nothing. This is the fundamental flaw, though. I can do this on, off all day. Like I can turn it back on, test, and everything just seems to work. But if I go ahead and type quit, notice it says quitting, but the application doesn't close. That's a flaw, and let me explain why. If we look at this, we are connecting normally, and if we add an extra comma here, you see there's a connection type. A little bit more advanced than what we're talking about now, but we use the auto connection type, and to do this specific thing, we can't, because it's on a different thread, and threads are way more advanced than what we're talking about. But we need to say Qt queued connection. So it does the same thing, it just connects to it in a different manner. So if you ever fire off a signal and the slot consumes it, but nothing happens, or I should say the slot tries to consume it, nothing happens, check your connection type and switch it over to queued, especially if you're in signals and slots across threads. Let's run that again. So I'm going to say test, nothing should happen. I'm going to turn it on, go ahead and test. We should see our radios. There we go. Go ahead and off, test it again, shouldn't see anything. And let's go ahead and try and quit this time. Now our application actually quit. We know because we get this press return to close this window, which means the application is not running in memory. And if I return, it goes bye-bye. As you progress through Qt, you're going to start hearing about property bindings or bindings. What are they really talking about here, and why do you even need them? Well, it's a bit more advanced than what this course really covers, but it fundamentally deals with QML and Qt6. Now, if you go all the way back to section 1, I mentioned QML and Qt6 because it is their cross-platform GUI system. So this is a graphic user interface that sits on anything from your cell phone to your desktop to a in-dash display on an airplane. I mean, it literally runs about everywhere. Now, it's a very complex topic, but they make it extremely simple. I have an entire course on QML, but you're going to hear property bindings over and over and over again, so I wanted to touch on them here. This is Qt6. And this is what it looks like. It looks kind of like a cross between cascading style sheets and JavaScript. It's kind of weird, but once you start working with it, it's just ridiculously simple. The back end, of course, is all C++. The major thing here, the major takeaway is you have properties, for example, height and border, and you want to be able to bind those to some sort of back-end class. Set binding, width, border, things like that. So to make this magical feat happen, they use, of course, signals and slots, which is what we're talking about. So we're going to look at the Qt property system. We're not going to touch on QML. I just want to introduce the concept of the property system, and we'll use it later on in different courses, and we'll get much, much more complex. Just want you to be aware that when somebody's talking about a property, really what they're doing is using signals and slots under the hood in a very fancy way. Let's go ahead and let's make a class. So I'm going to say add new. Let's call this test. Of course, because we're using signals and slots, we have to have a Q object. Next, next. And no, I don't want to Add that. Thank you very much. And then let's go add new. Let's make another class. Let's call this watcher. If I could actually spell watcher. There we go. Of course, should be a Q object because we're using signals and slots. And then let's just update our CMake list. Save, make sure it gives a good parse, and we're good to go. Now we're going to dive in here, and we're going to do something a little bit different. What I want to do is right here in the private section, I'm going to say QString, and let's say m_message. Doesn't really matter your naming convention, just as long as you're consistent. This m underscore denotes that this is private. So I'll never use this outside of the class. It's always going to be internal. Now, it's simply just the way it's spelled. If I wanted to make it public, I could definitely move that down here, but I'm going to show you why we want this private. We're going to use getters and setters. So I'm going to right click, refactor, and create getters and setter member functions. And notice that Qt Creator, because we followed Qt's kind of style here, has automatically parsed this out correctly. We have message and set message. Works as expected. Now I'm going to add in a signal. I'm going to say void message changed. And let's go ahead and say QString message. Typically, we're going to fire this off in our setter, so we're going to switch over here, and let me get rid of that so we have some screen real estate here. So in our set message, we're going to go ahead and emit that the message changed. And then we're going to, of course, emit our message. And because this is a Q string and not a Q object, we can definitely copy that. If you wanted to emit a Q object, you'd use a pointer. Very, very simple. In our setter, we're just going to set our internal private variable, and then we're going to emit a signal saying, hey, it's changed. Now, from here, and especially if you don't like it like this, I'm just going to do a little copy paste. For whatever reason, I'm very picky. I like my constructor at the very top so I can see what's happening when the object's created. We've got a blank constructor. We have our getter, and we have our setter. This is not a high-performance fancy class by any means. But what this has done now is laid the framework for us using the Qt property system. We can go into our public section here, and we can make a property using the Qt property macro. I'm going to say Qt property, and you notice there is a private property. We're not going to really touch on that, but there's Qt property and then the template. And you have a type, a read, a write, and notify. Very important you understand. We're talking a type, and this is an actual data type. Something happens when we want to read, something happens when we want to write, and something happens when we want to get notified. So that is our getter, our setter, and our signal. It's very simple. And if we do it like this, we can just say, okay, so what type are we working with? Well, we're going to work with a Q string. And we want to call this message. You can name this anything you want. This is the name of the property, not the variable. But because I've followed a naming convention, you know what's happened as I've typed. Message is now going to read message, our function. It's going to write set message, our function. Notice that's misspelled though. And then, I shouldn't say misspelled, case sensitivity is goofed up. And notify message changed, case sensitivity is correct. So we have our property, our getter, our setter, and our notification. And we can mix and match these at a minimum. We can get rid of those and just have a property and a read. But I want a getter, a setter, and notification. And this is the property bindings that QML would use to interface with this class. Vastly unhelpful for what we're talking about. But again, I really wanted to touch on the property system. Now we need to address this guy right here. Notice how that case sensitivity does not match. We have some choices. We can either change it here, or we can try to change it here. And if we do, Notice it changes the case sensitivity for everything. That gets super, super frustrating. There's a simple way around it, though. You can either A, comment it out and then change it, or you can type it out and then see if I can get it to do it. Sometimes it does, sometimes it doesn't. You can just go here and then hit enter, and then once in a while it magically finds it and changes it. But usually you have to comment it out. After you've hit return once, it usually stops trying to modify it. But if you find that it continually tries to modify it, you just simply comment it out, modify it, and then uncomment it. So what does this really do for us? Well, we're about to find out. But basically, instead of calling a getter, a setter, and connecting to this signal slot, we can just simply work with the property. That's not always true inside of C++, but from a QML perspective, it is 100% true and very, very easy, because then you just modify one thing instead of three. All right, so now we've got our watcher, and this is going to work with that. This is going to be our consumer here. So I'm going to say include Qdebug, and I just want a slot. So I'm going to actually go to our test here, grab that definition. Refractor, and notice how I've got it in the signal, so it's not going to work. Let's go ahead and do public slots. All right, now magically does work, and we can add that in. Very simple. I'm just going to say QInfo, and we're just going to pump that out. Now, going back here, in case you're wondering the difference between signals and slots, remember, just quick review, a signal does not have an implementation, which is why when I right-clicked on it, it wouldn't let me add it. I had to put it in a slot. There are such things as public slots and private slots and protected slots. We're talking public, meaning anything outside of this class can also see this. If it was private, then only this class. If it was protected, then it was this class and anything that inherits this class. Now that we've got that, very simple. Just going to close all this out. Let's give it a good build just to make sure everything's working as expected before we continue. All right, now let's jump into our main, and it's go time. This is ridiculously simple, but I absolutely love it. Once you get into QML, this is amazing. So we're going to say include, and we want to include the test class. We're going to go ahead and include the watcher class. And we want to add in what's called a Q variant. So we're going to include Q variant. And this is a class that's baked right into Qt, but what it really means is it's just a variant, which is an unknown. So this is a wrapper for other data types. QML doesn't really have a strong data typing concept. It's not really true, but when you look at it, you can define something, but you can also just say var or some other loose type, and then it just figures it out. That's changing rapidly, and I've noticed that some things just don't work the way they used to, but point being, almost everything at the QML level is wrapped inside of a Q variant. So what we want to do here is, because we're working the property system, we're going to work with variants as well. So let's go ahead and say Q, actually let's make our test class first. So I'm going to say test, let's call this tester, and then watcher, and let's call this destination. Just kind of coming up with random names, doesn't really matter. And let's go ahead and connect these up. Now, because we're in C++ land, we have to manually connect it. If it was in QML, it would just automatically connect for us. It's called a property binding. So Q object connect, whoops. And then we're going to go ahead and connect our tester with the test. And we want the message changed signal. We want to connect that to our destination. And we want, of course, give that the watcher class. And we want to give it pointer to message changed. I should say the address of message change. There we go. Now we have that signal and slot all set up. From here, what we can do is actually set the property. And this is where it gets a little bit confusing. But if we were in QML, we would just say tester.message. But notice how in C++ it's trying to call the getter. So we can't really do that. So in QML, you would just say something like this. Can't do that in C++ because C++ is, well, much more confusing sometimes. So instead, we are going to manually set that property. And this all happens in the background for us in QML. So we're going to set a property. Notice it wants a string, I should say a const char pointer to. And we're going to say Q variant hello world. This seems overly verbose and chatty, and it's because we would pretty much only use this when we want to do some sort of QML interface. Now, some higher level codes do actually work with QProperty, but for the most part, I use this primarily in QML. And then we can go ahead and say tester set message just to prove that our setter actually works too, so we can call raw C++ code. And let's see these in action. Save, run. So we have hello world and testing. Now let's track where both of these are coming from. So set property, again, we have to do it this way because we're in C++, is going out and looking at that class and looking for a property called message. And sure enough, we have one right here. We have a Q property saying message. We've defined the data type, we've defined a getter, a setter, and our notification, which is our signal down here, message changed. So that all hooks into the property system. And then, because we've set the property, we can hand it a Q variant saying, hey, here's the data wrapped inside of a nice Q variant. And the property system knows exactly what to do with it. And in the background, it's going to call the code that it needs to call in order for this to work. Again, this is primarily for QML, something vastly out of scope for this course, but I want to touch on it just because you're going to hear property bindings over and over and over, and you're not going to have a clue what they're talking about. Let's take a look at a timer example. This is a little bit more complex, and it's going to use a class we haven't touched on yet called the QTimer. The thing I love about Qt is that their documentation is world-class. Usually just go out to Google, type in the name of the class that you're looking for, or just put a Q in front of it if you don't know the name. So I literally said, I want a timer, so I put a Q in front of it, so it's QTimer. Make sure you're in the right version of the documentation. We're talking about Qt6 in this course. And then there you go. It says a QTimer class represents a repetitive and single shot timer, meaning we can repeat over and over like a clock, or we can just wait and then do it one time. And it shows you exactly what we need to do. So for our header, we just simply include this guy. So I'm going to just copy this. And then it shows us CMake and QMake what we need. We already have Qt core. We can verify that, but also inherits Qt objects. So because this is an object, it has signals and slots. Let's jump in here. We're going to look at our CMake, and sure enough, we are using Qt core. There's no doubt about that because we are, well, using Qt, and Qt core is needed to work with Qt. Now in our test, this is what we're going to do. We have a class, and we're going to include that QTimer. And let's go ahead and include QDebug, just because I want to print things out. And from there, it's very simple. We just figure out what we want to do and how we want to do it. So we're going to go back to the documentation, click on More, and usually there's an example. So for example, QTimer, and it's got a pointer to a timer equals new timer this. You don't necessarily need to make a new one. You could actually do this on the stack if you wanted to. And then you can connect signals and slots. And then you're going to say timer start. Or you could do a single shot. It's actually very, very straightforward, very simple. I love how their documentation is just very smooth and very easy to understand. And if you're really, really good at documentation, you can read through all of this, but usually if you just click more, it takes you pretty much right to what you're looking for. So we're going to kind of deviate from this. We're not going to make a pointer, although you can. You don't really need to. Let's go ahead and go in here. And I'm going to make public lots. And let's say void timeout. Now I'm going to add a private section. Again, you can, as a matter of taste, you can either do it up here or you can make your own private section. Doesn't really matter. I'm going to say QTimer timer. That way it's right on the stack and I don't have to worry about memory management. However, you notice how their pointer says new QTimer, and then it's got the parent in there, which is a Q object. So they're using that parent-child relationship in terms of memory management. All right, so we've got this guy, and we want to connect the signal from the timer to our slot. You notice this is all in one class. So I'm going to go here, and I'm going to just say this dot connect. We don't really need this. We could just say connect. Maybe if I spell connect correctly. There we go. And then we're going to go ahead and connect our timer. And we want the Q timer. And we only have 3 signals: timeout, destroyed, and object name change. So it's fairly obvious what we need to do here. We want the timeout. Get rid of those annoying little brackets. And then we want to connect it to the current object, which is this, which of course is a test class. And we need a slot, which is timeout. Notice the little icon there. Looks like a little plug or an outlet that we can plug something into. All right, you notice what we don't have is an implementation of that slot. So let's go ahead and do that now. We have 2 ways. We can either manually type it out, or we can go back out to the header and simply right-click refactor and then add definition. And voila, it is just there for us. Very cool how that works. Say QInfo, and then I can say test. And from here, we have some options. There's a billion different ways we can do it. We could, deep dive through the documentation if we wanted to. You can see how we can start and then we can delay it in milliseconds. We could do a single shot, whatever we wanted to do. I'm going to go ahead and I'm going to say timer. And if ever you're curious what sort of things are out there, always look for the setter. So I'm going to type the word set, and then here we go. Set interval. Right off the bat, first thing I want to do is I want to be able to say, all right, good. In milliseconds, let's do this once a second. So a millisecond to a second would be 1,000. So we have 1,000 milliseconds in every second. Now, we want to go ahead and start our timer. Notice how there is multiple ways of doing this. There's start as a function and start as a slot. There's virtually no difference. It's just one lets you connect via signals and slot, and one lets you do it via just a normal C++ function. Remember, a slot is also, well, you guessed it, a function. But you notice the definitions here. This is a standard chrono milliseconds value for the start function versus the slot is just an int millisecond. So I'm just going to go with this one. Literally, if you type it, it doesn't matter. See, just overloaded. And I'm going to go ahead and start that immediately. There was also, just in case you wanted it, a stop slot. So you could start and stop. Just going to put that there. And I'm going to comment it out just because I want to do this timer repetitively over and over again. But I just wanted to let you know that you can actually stop the timer if you wanted to by calling timer stop. So if you wanted to do it once a second for so many seconds, you could do it right here. And then let's go into our main. Go ahead and include our test class. And let's make an instance of it. That's all in our constructor of our test class. So looking at it is just going to immediately connect our signal slot, set the interval, and then start the timer. Let's save this and run. Let's see what this looks like. So every second it's going to fire off this test, 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 test. It's just going to keep going repetitively. Now, if I close this, on my system it's saying close terminal and it will kill it. On some systems it's going to keep it alive. If you notice it's hung, you can go out here in the Applications tab and you'll see, like if it was churning away in the background, you'll see this little red square. You can just simply stop that and it will stop the application. So when you get into timers and threading and things like that, you may notice sometimes on your platform that it will actually do that and you'll have to stop it manually. That is just because we haven't really talked about how to stop the programs when you're done with your threads, because it's more advanced than what we're talking about. Let's go ahead and finish this thing out here. So I'm going to say int count, and let's go ahead and switch back in here. We're going to grab this guy, and we're going to say count equals 0. I just want to initialize that variable. Let's grab this, put it right above. Now, what we're going to do is stop this timer after so many counts. So I'm going to say count plus, and then if count is greater than or equal to, we'll say 3, then I want to say timer stop. So we're going to go ahead and stop the timer after so many seconds, in this case 3 seconds, because this is going to be fired off once a second. So if we're greater than or equal to 3, we're going to stop the timer. Save, run. Ridiculously simple the way this works. I've worked with timers in other frameworks and languages, and it's much, much easier in Qt. You can see after 3 seconds we've stopped. We could add a QInfo in there indicating we're finished, but I think you get the point. Let's go ahead and just do it, just because someone out there is going to say, how do I know when it stopped? And rerun it, and let's see this example. 1 1000, 2 1000, and 3 1000. We're done. Now, so far I've been painting this, rosy picture that Qt is great and that everything works perfectly and there's rainbows and kittens, and I'm going to show you that's not always the case. So we're going to talk about the dog owner. Why? Because we can easily goof things up. Now, what are we going to do here is we're going to take an owner, just going to represent like a person, and a dog. And anybody who's had a dog, especially a puppy, knows you can get dogs wound up really fast, especially if you've got a treat. So we're going to look at or deep dive into the connection. When I say connection, we're talking about QObject. So if we go into QObject and we just kind of scroll down, you see there's a lot of different connects. And if we just click on one of these at the very end, you notice how it's got the Qt connection type. So click that. And it is by default the auto connection. What does this mean? So let's click this. There's different types of connections. Auto, I think we've touched on this briefly before, but auto will just try to figure out what you're doing. Direct goes directly to that object. Queued puts it in a queue. This is really great for threads. Threads are very advanced and go beyond the scope of this course, but we do cover them in our Qt Core Advanced course quite heavily. And then you have blocking queued connection, which is a little bit unique. And then unique connection, which is, well, unique, meaning only one of them can be connected. So it actually uses the object to figure out how many of them are connected. And then you have single shot connection, meaning you're only going to connect to it one time. There's others as well, but it gets a little bit more deep, and well, you don't really have to worry about it too much. Now, when I say others, yes, using bitwise OR. So you can actually mix and match these. So you can do like a unique single shot or something like that. It gets very complex under the hood, and you can kind of make your own little case scenario. Let's go ahead and figure this out. Now, by default, these are all auto connection. I want to show you how and why we'd want to use like a unique connection. So let's go into our owner, and let's say we want a slot. Actually, let's do signal. So I'm going to say void treats. You ever have a treat for a dog, and boy, they get all kinds of wound up. Now I'm going to make a function, and let's say, I don't know what to call this. Give snacks. And in here, we're just going to refactor, and we're going to just simply emit that we have treats. And this would be like the equivalent of shaking the treat box for your dog or whatever you wanted to do. So the give snacks is just going to emit that we have treats. And if we wanted to, we could prettify this a little bit, say Qt6. And let's go into owner and just say, hey, snacks are ready. And that usually gets the dog's attention. Now, very, very simple class. I'm just demonstrating we're emitting here. We're only emitting one time. Now, if we go into our dog, this is where, well, things are going to get a little bit different. So I'm going to say include Qt6. And we don't want a signal, we just want a slot. So I'm going to say public slots. And again, what I like to do is just take that and do the old copy paste. That way everything lines up, makes it super easy to read. Then right click refractor, and then let's go ahead and add that in. Now I'm gonna just say Q info, and the dog's going to, of course, get all excited and bark because we have a treat. But it's only gonna do it one time. Very important you understand just once and only once. All right, now we're gonna go ahead and include these. Make some instances of them. Notice we only have one instance of each. We're just saying 1 and 1, not a big deal. Now I'm going to do a Q object connect. And then I want to say dog. Actually, let's go ahead and connect that owner to the dog. Got a little ahead of myself there. And we said we got treats. And our dog is going to love those treats. So we're just connecting the signals to the slots. Now what's happening here under the hood is we are doing a auto connection. Because that's the default. Now I'm going to just say owner dot, what did we call that? Give snacks. That's why it's not coming up. There we go. Which of course is going to emit that we have snacks and the dog's going to bark. So let's just run this just to show that this is going to work the way we expect it to. Snacks are ready bark. Okay, we expected that, but now let's look at the complexity here. Let's say somewhere else in the code, whether it be a function, a class, but somewhere else, we do something like this. What's happening here? We have the same objects, but we have two different connections. Notice how it barks twice. That's right. So every time that signal is emitted, it's going to trigger the slot for every connection we have. So for example, if we do something like this, for int I equals 0, I is less than 10. So we're just going to do a for loop, and we're just going to connect that up. You might guess what's going to happen. That dog is super, super excited. He's way stoked to get that treat, even though there's only one object of each. There's only one owner, or there's only one dog, but we're seeing that fire off multiple times. That's exactly what's going on. Is somewhere in your code, you have reconnected that, and it's using the auto connection. And that is where you need to really understand the connection types and figure out which one's right for you. Now, if you do, let's say, a Qt connection, for example, what can we expect? And this is just to demonstrate, it's literally the same thing. So the only way you're going to get through this is if you look at this, really read this and understand why we need a Qt connection. Flag can be combined with any one of the above connection types using a bitwise OR, when a unique connection is set, QObject connect will fail if a connection already exists and the same signal is already connected to the same slot. What does that really mean? Well, it means if we do something like this and try to run it, you notice how it only barks once. We don't get a compiler warning, we don't get an error, but it only fires off one time because we've already been connected. Now, if we close this and look at our compile output, we actually don't even see any sort of warnings or errors or anything like that. It just doesn't even worry telling us. Sometimes, once in a while, I will admit, you will see something creep up, especially in QMake, where it's going to say, hey, like warning already connected, but it doesn't actually issue the warning in the application output or in the compile output. It's just bizarre how that works. But 99% of the time, you're going to want the auto connection. But if you start having weird issues where one object is firing off the slot multiple times, switch over to a unique connection.